Yeah. Good evening, everyone. So, again, let's start off. This was the last thing that we did. I hope everyone went through the notes once, but anyways, let's do one or two more on this. Other scams on. So let me just brief this up once more again. Why do I feel like it has been a long time since I saw you guys? I'm getting a feeling as if it's like 1 or 2 months. Let's see. Who else? Other scams on. People are still missing. So just let me brief this up. So the concept behind this is if there are two mirrors, right? And who is the object here? So if you have this angle set alpha and beta made with that the mirror ka point here. So this is how we do. The first image that is formed by the M1 will be at an angle alpha. That means that is somewhere here, alpha. Right? So that will form so this is the image formed in M1. And beta is image formed in M2. So then you just keep adding, beta plus theta. So this is the image, beta plus theta is the image of this image, which is formed in M2. So image ka image tha, it is forming, you're getting it. And you keep adding theta, theta, theta till, you have to keep doing this till the angle exceeds 180 degrees. If it is exactly 180, we don't care. You should take it until less than 180. And then finally, if you add all these angles, if it comes equal to 360, that the last two images coincide. Example, look at this thing, what we did. So here we have two mirrors, M1 and M2. Right. The first image is, so here object is somewhere here. So the first image forms at an angle of 10 degrees. So this is your first image in M1. The second image will be 10. The angle between them is 60. So 10 plus 60 is 70. 70 plus 60 is 130. 130 plus 60, 190. It exceeds. So you stop here. Done. The other one, the other angle is 50. 50 plus 60 is 110. 110 plus 60 is 170. After that, it is gone. So in total, we have around 6 images. And when you added all of them, we get 360. That means this 130 ka image and 170 image coincide. So in reality, there are only 5 images. Got the basic idea about it? Let's do one problem and then we'll do one or two problems. We'll get the hang of this. Let's say we have a mirror M1, we have a mirror M2, we have an object here. This angle is 30 and this angle is 20. Find the number of images. Theta would be the angle between them, so that is 50 degrees. Find the number of images. And they can ask you find the location of the images. If you just want the number of images, you can directly use this formula, 360 by theta minus 1. So here 360 by theta is an odd number, so we have to use the second case. And if the object is not on the bisector, so it is 360 by theta minus 1. So if you just want number of images, that is the fastest way to do. You want the position, then it is messed up. Who is missing? 3 people are absent. Diwali ka vacation, right? We'll be having a break from 10th and 11th of November. That means we'll be having a class on next Friday. And PACE ka portion for the next major test also. It is humongous. As usual, every year they do that. End May they will leave half of thermodynamics, so don't worry about that. Mostly they'll finish off center of mass, rotation, and ray optics. I don't think they'll do heat and thermo, but let's see. They have a habit of doing that. They'll leave one chapter, end May, they will rush 3 months ka portion in 1 month and say portion is over. It is the same story I'm seeing from last 4 years. So let's hope they will change this time. You don't worry about that. You focus on solving, you will get your things done properly. So let's see. M1, M2. So my first image will form at 30 degrees. And then you add 50. You get it 80. Then you add 50 again. You get 130. Again, you add 180. So this is gone. You can't exceed 180. And for M2, the first image will form at 20. Again, you add 50 for this 70. 120. 170. This is fine. And that's it. So 1, 2, 3, 4, 5, 6, 7 images. And you know the locations also. So that means if I just look at this M1 ka mirror, I'll just give you an example here. This is the object. So the first image will form here, I1 at an angle of 30 degrees. Then the second image will form at an angle of 80 degrees. This is the image in M1. Then the next image will form at 130 degrees. That would be something like this. These are the 3 images which are formed in M1. You're getting this? Similarly, if you take this guy, M2, so this is the image here. Let's call it I1 dash. That is this 20 degree wala. So 20 from there. And then 70, meaning from here you have to take 70. Somewhere here. And then 120, 170. So we have there I3 dash, I4 dash. So basically we are taking about always this angles you're taking. This is 120. This is 170. So all this will be on a kind of a circle. If you join them, you get a circle. Clear with this? So basically this image will form in M2. This image on this thing and so on. No, wait, I did a mistake here. Shit, I wrote, no, this was 70th actually. Yeah. I goofed up the angles, that shit. Yeah. Sorry, I goofed up the angles. This is M1. This is the object. This guy was 30. So this image will be first here. So this is your first image. Let's call it I1, I2, I3, I4. There are 4 images in M1. 30. Then the next image is at 70. Which is I2. The third is at 130. The fourth is at 170. Clear? Everyone got these angles. Similarly, I can do for the other guy. I'll just draw it separately better. This is O. This is M2. This is 20. This is, let's call this thing I5, I6, and I7. So there are 3 images here. I5, this is 20. This is 80. Something like this, 120. Okay. Let's see one more like this. So basically, it is useful to look at the position of the images also. But if they just want number of images, this is too lengthy method, waste of time. Turn in the page. Any doubts on this? Let's see one more like this. This is 30 and this is 35. Get the number of images. If you get 6.2, yeah, you round it up to the nearest integer, 6. You get something like 6.2, make it 6. How do we do this? Yesterday is Halloween, it seems. So today the medical batch students were asking, sir, like, did you celebrate Halloween? I said, physics teacher, no need to celebrate. Being a physics teacher itself is a big Halloween monster. If you say there's a vampire, people will go and see, "Arey, chalo dekhte hain." If you say there's a physics teacher, people will start running. Especially medical students, for them, we are only big monsters. I said, not a bad idea, actually. Next year, say we can have a new dress. They'll say, what is your dress? I said, physics teacher dress. And the best part, now all the medical students actually agreed to it. I said, like, sir, makes sense. Kitna tha? Someone got 6. Any other answers? You have to type in the chat box to the co-host, everyone. 6. Okay, we got 6 answers. Might be 6. Okay, looks like it is 6. Sure. M1, M2, 30, add 65, 95, add 65, 160, and you're done. I think you're exceeding. Then you have 35 plus 65, 100, 165, you're exceeding. Done. 6 images. Check भी करना पड़ेगा ना. 160 plus 165 plus 65. This guy is def 320, 70, 390. This is not equal to 180, 360, so it's fine. 6 images. The last 2 images are not coinciding. Clear with this? Easy? Great. Next one. Any doubts on this? Anyone not clear with this, please ask me. Maulika, clear with this? Vastika, got this? Vartika, clear? Great. Next one. Incomplete mirrors. So tell me one thing. What happens if you, let's say you have a mirror like this and you're standing in front of it and there is an image here. Now, let's say you take a hammer and break half of the mirror. Let's say you broke all this thing. And let's say the mirror becomes like this. what will happen to the image?
So the
If
side
mirror
of
is
the body,
broken, what happens to the image? Alright?
the part of the body seen already.
Part of the body?
So like the amount, the size of the image will ready.
Hmm. That means if I break the mirror, we'll get a tiny Lilliput size of yours. Something like that. Means if I see a big mirror, I'll see big gigantic figure of you. If I take a small mirror, I'll see a small picture of you. Someone is saying image is broken. So there was a question like this thing, huh? When I was in 11th or 12th, right, एक exam में आया था. I don't remember where is the question from, but listen to this question. The question was, you are a big photographer. Okay. So you're supposed to take a photograph of a zebra. Zebra. You know, a zebra that looks like a donkey with that black lines and white lines. So then, but what happened, right? There were no zebras around. So you came up with a brilliant idea. You said, okay, you have a, but what you have is a white donkey. So the concept of this, I will take a white donkey. Okay, that's a white donkey. Okay. So, and you decided that you will take a camera ka lens, right? Focus on the white donkey. Assume the white donkey does not move. Then on your lens, na, you draw lines such that when you look through the lens, it exactly looks like a zebra. So now, if you take a photograph, will I get a zebra? Is the question clear? You have a white donkey and you wanted to take a zebra ka photograph. So you came up with an idea. The lens is painted with some black lines such that the donkey looks like a zebra when you see through the lens.
No, sir, you won't get a zebra.
Such that the donkey looks like a zebra when seen through lens. So if we take a photograph, will we get a zebra? Now, and someone still thinks you get a zebra, right? Think of like this. So on your someone, if you're using glasses, you will realize this. So if I just put a dark line on my glass, will it look like there is a line on your face? Or just imagine like this. If I put a finger in front of your eye and if I look at you, does it look like my face got cut off? You'll still see the full image, right? Just because you put something in front of the eye between you and the object doesn't mean that person will look like that part is got cut off. You're getting it? So if we take a photograph, we still get a white donkey. The reason, see, you need to go back to the process of how light images are formed. So these light rays which are going here, it feels the light rays are coming from here. No, this is what you will see. So if this image is broken, mirror is broken, what will happen? These light rays will still appear as if they're coming from here, isn't it? But you'll get less light rays now. These light rays will just go off like this. So we get the image at the same place. But what changes then? We get a full image, we get the same thing. We get this image at same place. But with decreased brightness. Since the number of light rays are less, the brightness is less. Then what is the catch? Sorry. The catch is, if you want to see this image, you need to stand here. This is the field of view. If you stand here, this guy can't see the image. He can't see image. Image is there, but you can't see. Kabhi hua, you're sitting in an auto and going. If you sit in a certain place, you can see the driver. If you move to the side, you can't see the driver. It doesn't mean driver vanished, no? You're not in the field of view anymore. The mirror is so small, you can't see the full driver. So here, he can see. So if you break a mirror, the image will be at the same place, nothing changes, you get a full image. The only difference is the field of view will change. You need to stand at a different position to see the image. And whatever you see will be less brightness. Is this clear, everyone? So the same thing happens with this white donkey also. The light rays will pass through the remaining part of the lens. Whatever you made dark, that is okay. The light rays will just pass through the remaining gaps. So all rays from the donkey will reach the lens. You are just blocking some of them. So the image will be thoda less bright. So if you really want to take a zebra, what should you do? Paint the donkey. Isn't it? Make sure light rays are not coming only from this. This is a red donkey. Yeah, we'll take black. If you paint this donkey, then it will start looking like something. And you might be thinking, okay, big deal. This thing you must have noticed it. Ever seen this thing for boys? Now you will realize this. You look at yourself in the house in your mirror and you feel like, yaar, kya air bahut zyada ho gaya. I'm looking little jungly types. And you go to the saloon and you sit there and you look at yourself in the mirror and you feel like, yaar, I'm not looking that bad. Kabhi laga? That same face in the house looks a little weird, but suddenly in the saloon it looks good. Happens with the girls also. You buy a dress in the shopping mall, you wear it, you try it, feels very good. When you come home and wear it, you'll feel like, yaar, chutho gadbad hai. Matlab, it's the same thing. Everything is looking same, but there's something different. Felt that? Think about it. When you go to the saloon, how big is the mirror? Huge. There is a big mirror in the front. There's a big mirror at the back. So many light rays are reflecting. You get a very good contrast. You will look good. But in the house, what is the size of the mirror? Kind of little small. So you're not getting enough light rays, so your image doesn't look that bright. Now go back to the shopping mall and think. When you go for a trial, can you observe how is the room? There is a mirror in front, back, right, left, up, down, there's a mirror. What do you think? You think, Ariyar, there are so many mirrors so that I can look at myself. It is not for you to look at yourself. It is to increase the brightness. No matter what you wear, you will feel good only. लगता है यार ये अच्छा fit हो रहा है. You come home with the same dress and you wear and you'll feel something is messed up. Ever noticed that? The next time, Naveen, when you go for a shopping mall, why you have so many mirrors? And why you look yourself, you look good in the saloon, but not at house. Because in the house, the brightness is little less. You look little weird types. But saloon may go and see your face next time. It will be shining, glowing. Oh, sab dikhta hai usme. That basically we are using this funda here. The bigger the mirror, more light rays get reflected. You get a better contrast. That way. Clear with this? Great. Clear with this? Have a look at this. Any doubts, ask me. So if you use a part of a mirror, so let me just put the statement there. So a part of a mirror will create the image as a full mirror. Only thing the field of view have to change. And intensity will change. Everything else will be fine. Clear with this? Did you ever notice this thing? When you take a photograph and you look at it, it looks a little weird. Especially this, this marriage and all, bring this camera and take your photograph, no? When you look at that photograph, and when you look at yourself, you feel kuch to weird hai. You show it to your friends and family, they'll say, it is fine. But I think nowadays cameras come with that feature also to make sure. What happens, whenever you look at yourself, what are you looking at? You look at your image, isn't it? But when you take a photograph, left and right will get reversed. Whenever you look at yourself in the mirror, see the way your mom sees you and the way you see yourself are different. You're always looking at yourself in inverse. Now problem ye hota hai, human bodies, right? Even though we are symmetrical, we are not symmetrical. If you look at your face, right? Someone will have a right eye little big, left eye little small. Someone will have a left ka shade, little darker, right shade is little light. You're getting it? Maybe there's a pimple on the left, there's no pimple on the right. So when you're used to seeing that pimple or a spot on your face, every day in the mirror, and suddenly on the photograph it becomes reverse, you start feeling something is odd, but you can't notice what is it. So that uneasy, weird feeling that you have is because of the image inversion. So next time when you see there some of your worries, you will understand why it happens that way. Like every time keep saying your life is a lie. So yeah, can't do anything. So let's see this question. This is a good one. What if I have a mirror M1? This is a mirror M2. Someone broke this mirror exactly here. 90, 90. So there is no mirror here. And you keep the object here. Now, how many images will form? How many images will form? See what happens here. Like I said, the images you get, right? 4 kahan se aayega, God? If you have a full mirror, you'll get 3, na? If you had a full mirror, you would have got 3. Suddenly 4 kahan se aayega? Either 3 aana chahiye, nahi to kam aana chahiye. Now see what happens here. You need to understand how these lighters actually work. So from here, when the light rays go here, look at this thing. Not a single light ray, right? So this will be your first image here, I1. Not a single light ray from M1 will go to M2. That means M2 doesn't know that light rays are, that I1 exists. Normally, what used to happen, when you have this full mirror, some light rays from here used to hit M1, then they used to hit M2, and then used to go, no? So M2 used to think, Arey yaar, M1, I1 is also an object. But now what is happening, not a single light ray, right? Light rays from M1 do not go to M2 and vice versa. Light rays from M1 do not reach M2 and vice versa. So M2 does not know that I1 exists. Similarly, not a single light ray from M2 also will be here. So this is I2. So basically, normally, remember, I3, which used to form here, this does not form. Because I3 used to be the image of I2 on M1 and I1 on M2. The answer is 2 images. The third image doesn't form. But if you just extend the mirror a little, you're getting, even if you extend the mirror by little amount here, suddenly, right, some lighters from here will go here, suddenly 3 images will form. You're getting it? Even if you extend the mirror a little, 3 images form. Have a look at this. Yeah, that is a little about plane mirrors. Keep your cams on, everyone. Keep your cams on. Next thing. All clear with this? Any doubts on this? Please ask me.
Sir, so if it's parallel to the edge of the mirror, only 2 images will be formed. Na?
Parallel to the edge. हाँ मतलब भाई है ना, ये जो this is the last light ray ना, After this, every lighter will just go off. Nothing will come back again. So clear? So this is about plane mirrors. So next thing, curved mirrors. Turn in the page. The first thing, parabolic mirror. Now we don't have this, just a basic idea is important. So a parabolic mirror is special. In Max, you will learn how to draw a parabola. We'll not get into that. So for a parabola, we have something called focus. So if you send parallel light rays after reflection, they meet at the focus. This is actually the property of a parabola. Getting it? This is the property of a parabola. This does not work for any shape that you take. This only works for some specific shapes, like one is parabola here. So you might be thinking where you have seen this. Did you ever see this thing, on top of your houses now? This thing you have not dishes, antenna. That if you see that shape, that is actually a parabolic shape. And this signal which you have in the transponder, that is actually the focus. So when the signals come from here, they go and hit and go to the transponder here. So if you just want to harass your neighbors now, all you need to do is you just transponder and just push it to the side. They won't get a proper signal. That way. So that is the whole concept of using that disc kind of shape. The second place where you have seen this thing is ever seen in Royal Enfield ka headlight? It looks like a bowl shape. So the idea here is when you have a parabolic mirror, this is a paraboloid. You can do reverse. So if you put the bulb at the focus, the light rays will go parallelly. So the light rays will go for long distances. So vice versa. If you send parallel light rays, I'll meet at the focus. If you keep the bulb at the focus, you get a parallel beam. And if you have a parallel beam, you can make it travel very far distances. Quite useful when you're going on a road. You want the light to go as far as possible. And also in this, which one? Lighthouses. So they keep the main source at the focus. They actually use multiple things to magnify the intensity, but the basic idea is this. The problem with this thing is parabola is good, but construction is expensive. So parabolic mirrors especially used, right? These are especially used in astronomical telescopes. Not the one which you use in the house, but the big observatories. These are used in telescopes. In observatories. Heard about this thing, Hubble telescope? So Hubble telescope is one. So when Hubble telescope was launched, they did make a lens, actually, not exactly a mirror, but it was made of a lens. They did everything proper, then launched it into the space. After it went there, they switched it on. They started getting a lot of distortion in the images. They were getting only 10% of the resolution, which is expected. What was the mistake they did? They forgot gravity does not exist in space. When these people are constructing the lens on the Earth, they forgot to take the gravitation into consideration. So they assumed everything, it'll be gravity space in the constructed. So even though no matter how good you make, I'm sure you studied this thing. Glass is nothing but a amorphous liquid kind of thing. The glass, right? The radius of curvature changed by a few millimeters, and the whole resolution thing got messed up. So then these people in the next space launch, right? They sent some astronauts there to get it repaired. So it took them some years actually to get it sorted. But yeah, you have to be careful. People don't expect such things. So now the problem with this parabola is what? Too expensive for day-to-day use, right? No one wants to spend so much money. The construction is a mess until unless you need it. So we are just happy with spherical mirrors. These are easy to make, cheaper. So up to a certain level of error is acceptable when something is cheap. So if you take a spherical mirror, and if you send parallel light rays, this is what you see. We get an image which is distorted. You won't get a single spot. All of the light rays don't meet at the same spot. We have seen this, we did a question like this. Remember, where is that? Yeah, question. If you remember, r minus r by 2 sec theta. This was r minus r by 2 sec theta. This is the center. This was theta. That means for different points of incident, right? They meet at the different point there. Refer page 7. So the parallel rays do not meet at a single point. So you get an image which is a blur. You get a distorted image. How does this look? People with glasses, you will understand. If you remove your glasses and look at a bulb, how does it look for us? It doesn't look like a single spot, right? It looks like the whole thing got distorted. Blur जैसा दिखता है. Like this. Mhm. It kind of looks like this. The images will be blurred. You won't see a proper spot. Seen this kind of thing during rainy season when there's a water on the glass also you see something like this. People with the glasses, if you just remove the glasses, your vision will become like this only. That is the reason if you don't have glasses, it becomes very difficult to walk in the night time, on roads especially. Not because you can't see. Whatever you can see will be so distorted. Your image is completely covered with that light. And that's the best way to kill someone actually. Dispose their glasses and leave them on the road. Anyway, let's not do such things. Clear with this. So this is the problem with the spherical mirror, but this is called spherical aberration. Aberration meaning error. Spherical meaning it's a error because of being a sphere. So we have to come to a compromise. It is more cheaper to make this thing, so but there's an error. So up to what error is acceptable? Let's see. Any doubt so far? Please ask me. Clear? Next thing. So how do you make a spherical mirror? Take a sphere, cut it. So once you cut it, you get this, a part of a sphere. This would be your center. This point P is the pole. This R is the radius. This red color shaded region is called aperture. Aperture is the basically the region or the hole where the light enters. Area through which light enters. And if you take this thing, small r is the radius of the aperture. So be careful. Don't get confused between radius of the aperture and radius of the curvature. So this bowl shape, whatever you get, if you silver it outside, basically they use something like silver oxide or something. Or you can silver it inside. This line is your principal axis. I'm sure school may must have seen stuff like this. This is your convex mirror. No, this is concave mirror. This is convex mirror. This is how you create a mirror. Check it out. Be careful with the convention. Aperture, radius of curvature, pole, center. Clear with this? Next thing. So how do we minimize this error for the spherical mirror? If you send light rays very close to the principal axis, they still don't meet at the same point, but we can neglect that distortion. So this is height, okay, and radius of curvature is r. So if this height h is much less than r, these are light rays very close to the principal axis. We can assume, right, these rays are called paraxial rays. How small are we talking about? Let's say example h is 1 millimeter and maybe radius is something like 10 centimeters. Something like 3 to 4% error is acceptable, right? Then we can assume all these rays, we can assume this paraxial rays all meet at the same point. There is still an error, negligible error. Meet at same point, which is called focus. So this is theta. Basically, this is what you're calling as focus. So this is C. So C, F is R by 2. sec theta. So theta tending to 0, CF will become, this will tend to r by 2. So this length is pole to focus. This is r by 2, which you learned in school. PF is r by 2. This is called as focal length. Clear? So remember that if a parallel rays are incident on a spherical mirror, don't say always r by 2. There's a condition for that. The ray should be paraxial. Only then you can say r by 2. So our entire ray optics is based on this concept. So whenever we do in ray optics, everything, lenses, mirrors, all these things, we will do under the assumption that all the rays are paraxial, and we solve from that perspective. We can write in terms of PF if you want. Same to tha, r minus r by 2 sec theta, which will tend to r by 2, when theta tends to 0. Have a look at this. Now, in entire ray optics, the main thing is two things. One is the sign convention, one is the formula. If you know your sign convention and if you know the formula, questions will come quite easily. So unlike mechanics, where you can twist it and do a lot of nonsense, here it is a little less. Do have a look at this page. Chapter is quite easy, actually. Clear with this? The next most important one, sign convention. Can I turn the page? Mehan, Palaksh, go ahead. Swastika, clear na? Arjun, Vidyut, Venkatesh, clear na? Anusha, Yasha, clear? Great. Next thing, sign convention. Listen carefully to this. Now there are two types of sign convention. One is the geometrical coordinate system. One is the following the light ray. We will stick to one method. And this is the sign convention which we'll use for everything, mirrors, lenses, everywhere. The first one, the direction of the light rays is taken as positive. The direction of incident rays is taken as positive. Second, all distances are measured from pole. For mirrors, we call it pole, and for lenses, we call it optical center. Third, distances above principal axis are positive, and below are negative. Let me give an example that will make things much clearer. The convention we use, U is used for object distance. V is used for image distance. R is the radius of curvature. F is the focal length. Clear? Let me take an example. See, this is the same example we have taken before. for object and image ka concept. Let's say we have a mirror and a lens. Focus everyone, clear this. This is important. You got this thing, many things will be easy after this. Let's say letters go like this. They fall somewhere here. We get I1. This will go again here. They'll bounce off like this. We get I2. After bouncing off from here, let's say this is I2. Letters will go like this. Again, they combine somewhere here. Let's call this I3, and the letters are gone. So you have to, always when you solve problems, no, you have to keep moving the letters till all reflections, all refractions, all are done. Now, first thing. First, the guy is the lens. So if you ask the lens, who is the object? Who is the object for the lens? Who is the object? I1 is the image. That is one. Second thing, sign convention. What is the direction of light rays? When the object, say light rays are going, how are the light rays going? Right side. So the direction of rays is going towards right. So this side is taken as positive. Okay? Meaning this is what we do, everyone. So this is lens na L. We take this side as positive axis, this side as negative axis. So first thing, object distance, U. Where is the object, left or right? It's on the left hand side. So should I take plus or minus sign? Object distance is minus OL because it's on the left hand side. Image distance. Symbol is V, which is plus LI1 because this thing is on this side. So all distances are measured from the lens. So you treat the lens ka center as an origin and you start from there. This is treated as origin. So for this lens, right is positive, left is negative. Now the light rays are going to the mirror. So for the mirror, direction of light rays is still front. Remember the direction of incident light rays. How are the light rays falling on the mirror? I don't care about reflected light rays. I'm interested in incident light rays. So direction of incident rays is still right side only. So this side is positive. That means for my thing, this is the mirror. So this M is the new origin. This is positive, this is negative. We will not write like this later on, but for now, we'll do it. I1 is your object, I2 is your image. So U will be minus Mi1, V will be plus Mi2. Now light rays are coming back. Again, the lens. Now direction of rays is this way, so this is positive. So you take this side is positive and this side is negative. Your object I2 is here. Your image I3 is here. Now, if you ask the lens, what is U? It will say minus L, and L is the origin. Minus Li2, and what is V? Plus Li3. Please check this example. Quite useful. Please go step by step and try to understand. Once you got this thing, meaning you will, the sign convention is clear. So again, when you start from here, this is the object, this is the image, right is positive. So यहाँ से measure distance should be always measured from the center of the lens or the mirror, pole of the mirror. So for the lens, left is negative, object is on the left side, so minus, image is on the right side, so plus Li1. So object is minus and image is plus Li1. The light rays are still going to the mirror. Now see, when you talk about the mirror, don't talk about lens. When you talk about lens, don't talk about mirror. So when you talk about the mirror, so mirror I1 is the object, I2 is the image. So mirror will think letters are coming like this. So right side is positive. So Mi2 is positive, minus Ma1 is negative. When the letters are coming back, now this side is positive, reverse. So Li3 is positive, Li2 is negative. Please check this. This is the convention we use for lenses, mirrors, everything. You mess up one sign and the whole thing gets messed up. Understand, read line by line. Ask me if you're confused. Still confused, we're doing problems, will get more sorted out, but try to absorb this.
So can you explain for that mirror and the second lens? I didn't get that.
Mirror and the second lens. Abhi light rays कैसा आ रहा है? Light rays are this way ना, they're coming.
Yeah.
I2 is the object ना.
हाँ.
तो ये positive है ना अभी. So left side is the positive x-axis, right side is the negative x-axis.
Okay.
Object कहाँ पे है? Right
basically
side पे है. हाँ,
हाँ.
you always go with the light ray. Light ray जिस तरफ जा रहे हैं वो positive है.
So the direction of that incident ray, the taken as a positive.
हाँ, that is always positive.
Okay.
See ना, light rays from I2 are coming this way, right?
हाँ.
तो ये लेंस के लिए ये incident rays है ना?
Yeah, so that's positive.
That is positive.
Okay.
We stick to the light rays. We always go with the light rays.
So we can say we are seeing with respect to the incident ray.
You're always following the light rays. So that, yeah, basically always taking the light rays as forward direction. That, keeps things better for our perspective also. It becomes more easy to follow one after another. All clear with this page? Anyone not convinced with anything? Thoda confusion, you can ask. Still, you got the hang of it. Let's do problems, you'll get the hang of it even better. Look at this page. So there, so the direction of the incident rays is positive. All distance are measured from the pole or optical center. Distance is above positive and below negative. Yeah. Clear?
So could
Can I
you
go
show
ahead?
the previous page?
Yeah. Ansha, go ahead.
So
हाँ आर्यन बोलो ना.
नहीं सर
Nothing?
कॉपी करना था बस.
Yeah. Your senior ka portion is done. We started with the speed test yesterday for them. 60 questions, 1 hour. Highest is 161 out of 240. They forgot all basic stuff. There is a question. There is a question like this: particle is projected to 10 meters per second. Find the time when it stops for the first time. To you भाई लिख लिया सब लोग. So there's a pressure of time also. Basic things they forgot. Happens. They'll need at least 4 to 5 tests for them to get the hang of it. Then they will do. Next test is 75 questions, 1 hour for them. So most people did actually. Most people did 50, 55 questions, but they did a lot of mistakes. 13, 14 mistakes ho gaya. Let's see. Clear? Going ahead. No, still convention, right? About the radius of curvature. Even R will have a sign. Now look at this thing. Listen to this. So if you have a mirror like this, concave, and this is your object. So tell me one thing. How are the light rays going? This way, right? So this is positive. And that is negative. Where is the center? Let's say center is somewhere here. This is a pole. So radius of curvature is this distance. How much? Radius is minus PC or minus R. Is that making sense, everyone? Even radius of curvature will have a plus and minus sign. Example, let me take a number. Suppose if I take a thing like this, if we keep the object here, and let's say radius is 10 centimeter. So is radius plus 10 or minus 10?
minus 10.
So basically, center will be somewhere here. The lighters are going this way, so this is positive. Center is on the negative side. So R is minus 10. Suppose if you have a mirror like this, let's say radius is 20 centimeter. Object is here. Now, lighters are going this way. This is positive, left side is negative. Where is the center for this mirror? Center will be somewhere here. The radius is
That's true.
plus 20. Suppose if you take a lens like this side is 10 centimeters, this side is 20 centimeters. Let's call this thing R1 and R2. And let's say object is here. अब इसका क्या होगा? So this is positive, this side is negative because lighters will go this way. So this is how we do for this thing. Huh? For R1, if you complete the circle, C1 is this side, agreed? So for the left hand side, the center of curvature is on the right hand side. So R1 is plus 10. For R2, the center of curvature is on the left hand side. So R2 is minus 20 centimeters. So for a lens, both the lenses will have different radius of, signs will change for each surface. समझ में आया? Same thing, if you have done this way, 10 centimeter and 20 centimeter, but this time if you keep the object here, now what will happen? Lighters will go this way. This is positive, this is negative. Now suddenly this becomes C1. So R1 becomes minus 10. So it depends on which side you're keeping the object also for a lens. This is C2. R2 becomes plus 20. So be careful. Depending on which side you're keeping the object, the sign convention will change. So even though these both examples are exactly the same thing, the sign convention is messed up. Let me give one more example. You tell me what is this? What if I give like this? I can tilt it also, big deal. Object is here. Let's say this one is R1 is 5 centimeters and R2 is 10 centimeters. Which one is positive, which one is negative? This is the object. Lighters are going this way, na? This is the positive direction. This is positive. This is negative. So this center is this way, C1. So R1 is plus 5. For R2, center is this way. R2 is minus 10. Making sense, everyone? Convention. So just complete the circle and देखो center किस तरफ है. Is it on the right side or is it on the left side? And see which way the lighters are going. What about the next example? Please ask me if you're getting confused. This is important. Lenses mein we are going to use this a lot. This is positive. This is also positive. Clear? Check the examples once. Have a look at the convention. So for even radius of curvature, you have to be careful because focal length is r by 2 and r plus or minus will change the focal length. Clear, everyone? These examples. Great. Next one. The formula for the spherical mirror. Now we'll not go into the derivation, they're waste of time. The reason it is because these derivations have so much approximations, they really can't do anything with this thing. We have to stick to that. And derivation जो भी है वो 11th HSC में है, so 12th में it is not there, so it is also useless for boards. We'll not waste time on that. We'll directly jump into the formulas. So spherical mirrors. You could have taken even convex also, just to give an example. So this is an object. Let us go, hit the mirror, and this is the image. This is your pole. O is the object. So the formula is 1 by V plus 1 by U. Everyone should note down this formulas, right? Copy it down. 1 by F. F is equal to R by 2. Magnification M, which is nothing but height of the image by height of the object. Is given by minus V by U. U is object distance from pole. V is image distance from pole. Basically, this is formula 1, formula 2, and formula 3. Three formulas. So important thing, U, V, and R should be taken with sign convention. Signs are important. This formula is valid only for paraxial rays. If the rays are going too far from this thing, we can't use this. Like I'm saying, all formulas we derived are under that assumption they're very close. Third, this formula is useful only. This is principal axis, no? Valid only if the object is on the principal axis. Later on, we will see how to do if it is not on the principal axis, but ये जो formula है, this is valid only if the object is on principal axis. Means if you keep an object somewhere here, lighters will go like this. We can do, but this formula won't be valid directly. Have a look at this. Note it now. Clear? Can I turn the page? Turn in the page. Let's start off with an easy one and then we'll slowly bump it up.
So can you go back for a minute?
Hmm.
Yes, sir, thank you.
Object is here. This is 30 centimeters. Find the position of the image. Just formula substitution. Find the position of the image. Sign convention. First you get U, V, R and dump it in the formula and get the answer. First thing, lighters are going to the right side. This is positive. So U is minus 30 centimeters. So meaning this is positive. Anything on the left hand side is negative. Radius of curvature is minus 20 centimeters because center is also on the left hand side. Focal length is R by 2. So that is minus 10 centimeters. V ka value, I don't know. There. Be careful with the signs. Then substitute in the formula. 1 by V plus 1 by U is equal to 1 by F. So 1 by V, U is minus 30 is equal to 1 by minus 10. That guy would be, yeah, it would be is equal to minus 15 centimeters. What is the meaning of minus? The meaning of minus is the light rays are meeting on the left hand side. So this is a ray diagram. 0. The meaning is this. The light rays are meeting here. 15 centimeters is the image. Got the meaning of that? Minus 15 indicates the light rays are meeting on the left side of the pole, opposite to the incident rays. Please check that. Ask me if you're confused with any sign, formula, anything. Get the B part. This side is positive. This side is negative. Try, I'll give you a minute more, everyone. Get used to the signs. So U is minus 20. Radius is plus 10. Focal length is 5. 1 by V plus 1 by U is 1 by F. So it goes that side. So 1 by 20 multiply 4 by 5. 4 plus 1, 5 by 20. 4 centimeters plus Plus indicates the image is forming on the right hand side. So this is the object. The lighters are bouncing off like this. And when you extend them, image is forming here. Uska meaning wo tha, it's a virtual image. The lighters are not actually meeting, they appear to meet. Think about it. See, can the lighters actually meet like this? They can't go into the mirror, right? They have to bounce off. So this is how you know whether it's a virtual image or a real object. This is a virtual image. Ray diagrams are important. That gives you an understanding of what is happening with the light rays. Have a look at this. Clear with this, everyone? Clear? Next one. Next one.
So can you go back for a minute? Just the time.
Let's say we have a radius 20 centimeters. You kept a thin rod. Whose length is also r, whose distance is also r. And r is 20 centimeters. So here AB is a thin rod along the principal axis. Find the length of the image. Find length of the rod's image. You know how to do for a point objects, how to do for a rod. Think. I'll give you 2-3 minutes. Twenty by 3 image length is 2r. Nare. What is the idea behind this? See, there's no formula for rod. That formula is valid only for point objects. So how do we do for these kind of questions? So these kind of questions, right? If you can find, think of like this. If you can find images of the extreme points of the rod, then all the remaining images should lie between them. The images of the other points will lie between them. So this is what we do. Consider we have an image like this. This will be A dash, this will be B dash. So treat each one separately. First, let's do for A. For A, what is U? Minus 2r. What is focal? What is radius of curvature? Radius is plus r only. Focal length r beta. I'll keep everything in r. Later on, I'll substitute. So 1 by v plus 1 by u is 1 by f. We'll stop writing this formula next. 1 by v by 1 by minus 2r is equal to 2 by r. So v will be 2r by 5. When you do the same thing for b, u is equal to minus r. R is plus r. F is r by 2. This also will stop writing from the next onwards. So 1 by v by minus r is equal to 2 by r. So v is equal to 3 by r or r by 3. So that means this B ka image from the pole is at r by 3. That guy is 2r by 5. Therefore, A dash, B dash will be 2r by 5 minus r by 3. That is r by 15. Check. R is 20, so 4 by 3 centimeters. That's how you find the length of an extended object. You take the extreme points because बाकी सब images उसका बीच में होना चाहिए. So you just treat them as two different point objects and finish off. Please check everyone. Is the logic clear, everyone? That is all for an extended object. So end of the day, remember, you know only that one formula for point object. Somehow we have to use that and manipulate that to get everything else. Check this out. Anyone not convinced with this? Any step you're not clear, please ask.
This logic we can only use when it's along the principal axis, right? Like if it's
Yeah,
straight.
along the principal axis, yes. Why, yeah, or else this formula itself is valid for principal axis, right? So A and B also should be on principal axis. Meaning if you make the rod like this, that looks pretty weird actually. If you make a rod like this now, you will get something like you'll get a curve. Straight line nahi aayega. Later on we will see. It'll actually be a curve. It will become very messy to solve.
Okay.
Clear with this, everyone? Same problem, I can ask you in another way. R is 20 centimeters. Here we have a small rod. But length is only 2 millimeters. It's just too small. Whereas this distance now is, let's say, 20 centimeters. Now find the length of the image. The 20 centimeters is to the center of the rod. This and the previous one, exactly same question. The only difference is the rod is quite small. So then we can do certain kind of approximation. Think for a minute or two, then I'll show you how to do this. How to do? So one way to do, right, is actually you can take the two ends as A and B. You take this as 20 minus 0.01 and 0 minus. This is very complex. Better way to do this thing is 1 by U plus 1 by V is 1 by F. Differentiate on both sides. This will become minus du by U square minus dV by V square. Focal length is constant, so is 0. So we get dV is equal to minus du into V square by U square. This is the small length of the object, isn't it? Du, na, the small change. This is the length of that object. Again, this you can use only for small object because you use differentials for small things. Then this will become automatically length of the small image. Don't use this formula for the previous case. Getting it? If the rod was big, this is blunder. If rod is bigger. So basically you're treating it like a point object with a small length. So 1 by V plus 1 by U is 1 by F. So 1 by V is E plus by minus 20 is 1 by minus 10 minus 9 plus 10. V is equal to 20 by 3 centimeter. Dal dena. So dV will be magnitude we can take. This is 2 mm. Into V square will be 20 by 3 and U is 20 ka square. 20 cancel hoga, 2 by 9 mm. Minus simply indicates image got laterally inverted. So the image forms at 20 by 3 with a width of 2 by 9 mm. So if the length is very small, use differentials. Yeah. We are just taking the magnitude, so minus 10 we are not taking. Do check this out. If the length of the rod is big, we have to do it the previous way. Take the two corners and do it.
Sir, but in this question, if we use the previous type of method, why will the answer be wrong?
The answer wrong nahi hoga. You will just go mad. Abhi my 1 by V
No, sir, I
plus
didn't
1 by
use
U.
method
ये क्या होगा 20 my point कितना होगा ये
2.
नहीं you have to take that side this side ना ये distance कितना होगा 1 mm right
हाँ.
so 20.1 होगा and अंदर will be 1 by 20 plus 0.1 होगा then calculate and solve you'll get the same thing if you become too complex we have to use binomial approximation
हाँ.
so if you're using approximation end of the day that means it's as good as differential you're getting what I was saying there so if you take that object here na till here it is 20 na so this will be 20 minus 0.1 this guy will be 20 plus 0.1 find the images of both of them and subtract them you'll get the same answer time consuming though clear everyone turning the page any doubts so far please ask let's say we have a mirror radius r this is the principal axis and we have one more mirror we have a convex mirror and we have a plane mirror and we have an object here this distance is x this distance is y find the condition if there is only one image normally if you have two mirrors there should be two images but for some reason you can see only one image then what is the relation between x y and r think about the meaning of the statement. What do you mean by only one image? So idea here is the image in the plane mirror and the image in the convex mirror are overlapping, isn't it? The plane mirror image and the convex mirror image are overlapping. That's why you're getting a single image. Or you should have seen two images. Try. Get it? Now I think you must have got that. How do we do this? Rx plus y2. Okay, might be इतना नहीं आएगा रे, थोड़ा डिसेंट आएगा. सिंप्लीफाई करके देखो. Answer is looking a little dangerous. So the idea here is the plane mirror image will form where? Let this image be I. Then if this is X, shouldn't this also be X? Because for the plane mirror, the image will form at a distance X behind. That means what is this distance here? X minus Y. So for convex mirror, U is minus Y, V is plus of X minus Y. The radius of curvature is R. Put it in the formula. 1 by V plus 1 by U is 1 by R. 1 by X minus Y plus 1 by minus Y is equal to 1 by R. Cross multiply minus Y plus X.
Sir, 2 by R.
2 by R, na? Focal length. Then something else I goofed up, right? ये U minus में नहीं है. X plus Y है. You should take distances from here, na? Minus of X plus Y. Minus X minus Y plus X minus Y by minus of X square minus Y square. It's 2 by R. X cancel हो जाएगा. 2y तो RY is equal to X square minus Y square. Check if this condition is satisfied. Yeah. Basically, this whole thing will be U for the convex one. ये image था. This would be x minus y. This is object. This would be x plus y. Got it, everyone? Easy? So the main idea is that whenever you hear the word there's only one image, what it means is they're overlapping. Clear? Next one, a little bit of theory. How do you trace these images exactly? Turn in the page. Tracing of light trace for a mirror. So in case of mirrors, right, there are 4 special light rays. Remember how you find an image, take any 2 light rays, after reflection, find the point where they meet, and that will be your image. The first one, if you send a parallel ray, it will pass through the focus. And that was the whole definition we started basically. Vice versa. You send a light ray through the focus, it will become parallel. If you send a light ray to the center, it will retrace the path. This also with the principle of reversibility. If a light ray hits along the normal, it will retrace the path. If you send a light ray at the pole, this will bounce like this, where this angle and this angle will be equal. Because the principal axis will be the normal here. Check it out. These are the 4 light rays. So using these 4 light rays, you can choose any 2 light rays from the object, extend them, and wherever they meet will be the image. Did you do this in school? ऐसा कुछ ray tracing diagrams? 10th ICSE, I think it is there, right? Object is at the center, image is at center, object is beyond center.
We
कुछ
have,
तो किया था ऐसा.
yes,
Same stuff. Have a look at this. It's fine. Even if you're not from ICSE, I'll still show you. Don't worry. Okay, it's there in CBSE also. There. Have a look at this. So if the object is at infinity, the light rays will come parallelly. Right? And they took one light ray passing through the center. So it will just bounce and come back here. So this would be your image. The image is real, inverted, diminished at focus. Object is placed between infinity and center. So this is the image. Image is real, inverted, diminished. Please go through the diagram once. I'm sure you've done this in school, so you can check it out. If you're still confused, let me know. I'll just explain you what happened. Like I said, you're taking any 2 light rays. I took one light ray parallel to pass through focus. Another light ray through pole, so it will pass through this. So point where they meet is the image. And you can clearly see the image is diminished. How do I know image is diminished? Look at this thing. This angle and this angle are equal. So tan theta is height by this. Tan theta is this height by this distance. So obviously you can see that height is smaller. That's how we know the height of the image is smaller. Height of the image is smaller than height of the object. That is the reason we keep taking the, that line passing through the pole. That will help you to get the height of the image. Look at these two diagrams. These cases are important, especially when they ask you some theoretical questions, whether the object is real, virtual, all those kind of stuff, it helps. Clear? Look at these cases. If you keep the object at center, you get the image at center. If you keep the object between center and the focus, then image is diminished, extended. It is beyond center and it is extended. If you place it at focus, you get it focus. If you keep the object between focus and pole, you get a virtual image. Clear, everyone? Any doubts on this? That is for concave thing. For convex, right? Luckily, there are only two cases. If the letters are coming from parallel, we get a virtual. In both the cases, it is virtual. The image is always virtual in convex mirror and direct. In concave, we have 6 cases, but convex, there are only 2 cases. Clear? This is just a summary there. Same thing, between focus, where is the image and all that thing. Better you remember this.
Hi, Mr. Vic here. I just wanted to do the one automatically. I tilt convex so the principal axis goes through the center of the mirror, and I pre-measured this is the center of curvature for this mirror, and the focal point is halfway between. And what I'm going to do between the mirror and
So basically, he took this concave mirror there. So he marked the point, center, focus, principal axis, everything.
the center of curvature. That it reflects straight back. So let me line up a little bit.
So there we're using a laser light here.
And you'll see that the light ray, as it passes on additional rays off the principal axis,
So you can switch on multiple lights. Can you see?
you'll see that these light rays parallel to the principal axis are reflecting through a common point, the focal point. In fact, I can turn on more.
Can you see the distortion? thoda they're getting messed up actually. The farther they go, they're getting little slightly messed up.
And you'll see that they all go through the focal point. Rays all we do as air to the mirror. Case of the mirror. Slide this over a little bit. Now,
Reverse. If you send it the edges from the other
reflecting
side.
through the, you'll see now that the
Now we are using the convex case.
light rays are the projections taker is a these up.
And the success criteria. The other
Yeah,
one
the
say this
same thing.
is the conic outfit.
Not
Here-
this one. Where is that guy? Lens. I think I have it for lens, I guess. I don't have it for mirrors. Okay, but I think you got the idea. We'll see it for lenses later on. Okay, so that's the last one for the day. So with that, we'll wrap up. So next class when we meet, we will see what happens if the object is placed above the principal axis. We will see what happens if the object starts moving. We will see all those kind of weird things. So next class, we'll finish off the curved mirrors. It's a simple concept there. And then if time permits, maybe we'll start off with a refraction little introduction also. So mostly before Diwali goes off red, we'll finish off up to refraction, curved surface and stuff. So once you come back, maybe it'll take another 2 classes. We'll wrap up ray optics and then we'll start off with center of mass collisions. Like I said, chapter is not tough. So this is there. Okay, so this is wrap up for the day. So any doubts, anything, please stay back and ask. Also free to leave. I'll see you on Friday at the same time. So take care, stay safe.